Question 32. Emily conducted an experiment to find out how the amount of heat would affect the time taken for the ice cubes to melt in the beaker of water. So we want to see how the amount of heat will affect how fast the ice cubes in the beaker melt. So over here is 3 identical beakers and identical candles. So in setup 1 or setup A, you notice there's only 1 candle. Setup B, there are 2 candles, and setup C, there are 4 candles. So over here, she recorded the results of the experiment. So in setup A, with only 1 candle, it took 11 minutes for the ice cubes to melt completely. And in C, with 4 candles, it took only 5 minutes. So this is the one that took the fastest time in setup C, and setup A is the one that took the longest time. So let's write down that C melts the fastest and setup A melts the slowest. Okay, and you notice in this time, we're actually using the superlative slowest, fastest, because we're comparing 3 different setups. Okay, so the first one, identify the source of heat in the above experiment. So the source of heat is actually the flame of the candle. Or even if you write the candle, it's fine. Alright, next, they ask, besides keeping the candle and the beakers the same, state 2 other variables that should be kept constant for a fair test. Okay, so there are a few things that we still must keep constant, even though we've already had the same beakers and candles, because there are other factors that can affect the amount of heat taken in that will affect how fast the ice cube melts. Okay, so I'm going to show you the possible answers. So the possible answers are the size of the ice cubes. They should all be the same. You cannot have 1 large ice cube and 1 small ice cube. The number of ice cubes also have to be the same. You cannot have a beaker with 5 ice cubes in one and another beaker with 2 ice cubes in another. Alright? Next, the temperature of water also has to be the same. So you cannot have one starting out at 100 degrees, then definitely the ice cube will melt faster. And then the temperature of the ice cube should also be the same. Temperature of surrounding, distance between beaker and the candle, the location of the experiment, and the amount of water present. Okay, the rest are also, these are also the other accepted answers. So same level, water level is also the same as the amount of water. The start time means when all the candles are lit at the same time. And the height of the candles are also important. Okay. Alright. In C, says that Emily made a cup of hot coffee and placed some ice cubes in it. She observed that the ice cubes melted after some time. Explain her observations. So why is it that the ice cube melted after some time? So it's because, so here we must see which is the warmer and which is the cooler object. So the warmer thing is actually your hot coffee. So above here I'm going to write that it's warmer or hotter. And the other thing that's present is your ice cubes. It's cooler, or you can say it's colder. Alright, so the reason why the ice cube melted after some time, and you're supposed to explain it. Okay, so why is it that the ice cube melted after some time? It is because the heat from the hot coffee has been lost to the ice cubes. Okay, or you can say that the ice cubes actually gained heat from the hot coffee or the surroundings in order for it to melt. Okay, so these are the acceptable answers. You can say that the ice cube gained heat from the hot coffee and melted. Or you can also say that the hot coffee lost heat to the ice cubes, or the surroundings also lost heat to the ice cube, causing it to melt. So any one of this is correct. So the principle behind you have to show is that the ice cubes either gained heat or that the coffee lost heat to the ice cubes. Question 33. Mei Ling lowered a flask with a glass tube containing a drop of ink into the basin of hot water as shown below. So when Mei Ling lowered the flask into the basin, she observed that the drop of ink actually rose. So you give a reason for her observation. So it's important to know that in the flask there is air, and this is water at 90 degrees. So water at 90 degrees is actually hot water. Okay, so although it's not stated that it's hot water, we need to know that it is hot water. I'm going to take note here that it's hot water. Okay, and inside the air in the flask is actually cooler. Okay, so what actually happens, or why is it that the air will actually rise after it is placed into the basin of hot water? It is because what actually happened is the air in the flask gained heat from the hot water, and this will give you 1 mark. So the key thing we're looking out for is the air. You cannot see the flask because it is the air in the flask that gained heat. And the second thing we're looking out for is that because the air gained heat, the air expanded and pushes the drop of ink upwards. So the other mark is given by saying that after the air gained heat, it expanded, pushing the drop of ink upwards. So this is how you get the 2 marks for this question. Alright, next. Mei Ling repeated the experiment by filling the basin with water at 10 degrees Celsius instead. So now instead of having 90 degrees, it is with 10 degrees Celsius water. And this we must know that 10 degrees Celsius water is actually cold water. Okay, so instead of having hot water in the basin now, it is replaced with cold water. So they will ask, what happened to the drop of ink in the glass tube after it's placed in the cold water? So the drop of ink will actually fall, or you can see the drop of ink drop. Okay, or you can say it became lower. Alright, so any one of this is possible. Okay, please take note that you cannot say that it will not rise, because even at this state, when the air is above the hot water or above the cold water in the room temperature, what happened is the drop of ink is not moving. So will not rise means that it is stationary, but in this case, because it's cold water, the air will actually contract, causing the ink to drop. So it will definitely drop and become lower. Question 34. Rodney conducted an experiment to find out how different materials can conduct heat using the experiment shown below. So you have a material, you have a heat source, and you have a beaker of water. So what Rodney did was to record the time taken for water in the beaker to boil when material X, Y, and Z were placed one at a time below the beaker of water. So the results below are shown here, and at the start of the experiment, each experiment there's 400 milliliters of water. Okay, so here you have experiment X, which took 30 minutes for it to boil, Y, which took 15 minutes for the water to start boiling, and Z, which took 25 minutes for the water to start boiling. Okay, so based on this, we can tell that 15 minutes is the one that is the fastest for the water to boil, and therefore we can conclude that material Y is actually the best conductor of heat. The reason is because conductor means it allows heat to pass through it easily. So if it's a best conductor of heat, it will allow heat to pass through it easily, pass through the material easily to boil the water faster. But if it's a poor conductor of heat like X or Y even, it will not allow heat to pass through it easily, hence it takes a longer time for the water to boil. Okay, so over here, which material X, Y, or Z is most suitable for making a cooking pot? So the answer should be material Y. Okay, and the reason for the answer is because from this experiment, we can see that Y took the fastest time or the shortest time for the water to boil. So material Y took the shortest time for the water to start boiling. So because of that, we can conclude that material Y is the best conductor of heat. Okay, so two things we must watch out here. From this table, we can see that Y is the fastest, took the fastest time for the water to boil. So we need to state it here that Y took the fastest or the shortest time for the water to start boiling. And then after that, we have to conclude that because of that, we can say that it is the best conductor of heat among the three materials. Okay? Next, if we want to use a material to make a container to keep food warm for the longest period of time. So you want to keep food warm for the longest period of time, we need to use something that is not a good conductor of heat. So from this experiment, the one that prevents things from heating up the fastest and the one's going to keep it warm for the longest time is actually material X. And the reason is because it took the longest time for the water to start boiling, and so we can say that it is a poor conductor of heat. And since it is a poor conductor of heat, it will be able to lose heat the start on a new line. So because of that, it will lose heat the slowest. Okay, so this is how you explain why we are using material Y. Okay, so because it is the poorest conductor, of heat, because we're comparing three materials, so we have to say it is the poorest conductor of heat, and hence it will lose heat the slowest.